Hello everyone. We continue with the lectures on uh, different techniques of computing limits of different functions. And this is technique number 4. I call this simplifying technique or simplifying method of limit computation. We have a big expression here. It's a rational expression. And if t approaches 0, the denominator approaches 2, and 4 over 2 approaches 2, 2 minus 2 is 0, so the numerator approaches 0, and so does the denominator, making this um, limit indeterminate form. So we end up with 0 over 0 if t approaches 0, this function approaches 0 over 0, which is indeterminate form. We need to find the answer. We need to use a technique, a method to find the limit. So the method here, as you see, there is no radicals for you to rationalize, and there is no polynomials to factor actually. So none of those methods in the past actually works. Even direct substitution method doesn't work because it gives you 0 over 0 indeterminate form. Therefore, you need to apply a new method, a new strategy, which I call it simplifying method. So in this case, what we do, we say, okay, we have a fraction in the numerator minus 2. Why don't we just do the subtraction in the top by finding the common denominator, which is 2 plus t. We get 4 minus 2 times 2 plus t. We all know how to work with rational expressions and rational functions. It's not the first time we're doing this. So we're going to try to continue simplifying after we subtract the two fractions in the top, because 2 is actually 2 over 1. We can think of it as a fraction. So that's a limit of 4 minus 2t all over 2 plus t all over t and then over 1, and t approaches 0. So continuing to simplify, we end up with negative 2t over 2 plus t and t over 1 clearly. Now here, let me show you a short trick of how we can further simplify this complex kind of fraction. Whenever you have a fraction like a over b divided by c over d, okay, so we can say that a and d are far from one another, but b and c are near and close to one another. So we say far by far goes in top, and near by near goes in bottom. So this is like a shortcut, a way of simplifying fractions whose numerators and denominators both are fractions themselves. For example, if you have 1 over 7 divided by 2 over 9, okay, if you want to quickly simplify this fraction, no calculators, of course, you're going to say 9 in the top and 2 times 7, 14 in the bottom. So 9 times 1 goes in the top, 2 times 7 goes in the bottom, 9 over 14 is the final answer, okay? So same thing here. We have negative 2t in the top over 2 plus t, and then t over 1 in the bottom. So using the same idea, I'm going to say 1 times negative 2 goes in the top, and then t times 2 plus t goes in the bottom. It's like a shortcut thing. These things are not in any textbook, actually. So when we meet, we talk about these little tricks here and there, and then you learn them, and then it helps you to do questions in future much faster. So we have a limit as t approaches 0 of negative 2t over t times 2 plus t. So now we only have one numerator and one denominator, and none of them are fractions, but they were fractions before. So this can be simplified. T over t cancels out. So we get negative 2 in the top and 2 plus t in the bottom. And this limit, if t approaches 0, the denominator approaches 2, and the numerator approaches negative 2, and that is, of course, negative 1. So the answer to this limit is equal to negative 1, as you see. How did we find the answer? Was this magic? No, it was not magic. We did it by simplifying. Next one, if x approaches negative 7, obviously the whole limit is indeterminate. So once again, we are going to find the common denominator in the top by adding the fractions in the numerator. So we get common denominator. Lowest common denominator is 7x. So we get 7 plus x, and here x plus 7, and x approaches negative 7, of course. And then using the same trick I taught you, so we're going to say 7 plus x times 1. Okay, that's in the top, and 7x times x plus 7 goes in the bottom. So you see how handy this like little trick becomes in doing these kind of questions. So x plus 7 cancels out. We end up with 1, which is left over in the numerator, and 7x in the denominator. So negative 14 is in the bottom, and the final answer will be 1 over negative 14. So that's how you find this limit. Okay, so I'll try to explain different techniques of limit calculation in the next lectures. Keep practicing, please.